In this video, I'm going to give just the general kind of ideas for integration by centroids and inertia, because there's a lot of equations and there's a lot to it. But if you kind of understand what you're doing with the integration, it's repetitive that you can keep doing in all examples of the problem. So starting with centroids for center of mass, technically, you're trying to find the x position and the y position. These are the two kind of equations that use the numerator and the denominator. And all you're doing is taking your arc or your curve or whatever shape you have, and you're splitting it into a bunch of small sections. That's how we usually think about integration. And if you're using this equation, you're keeping your x and you're keeping your y. The only thing you're changing is your d of a. Your d of a is just your area of that section that you're taking. So if you're looking at the area of a rectangle, it's height times width. So you're taking dx times y. Your y is going to be in terms of x, which makes sense because then you're solving with an x and d of x. Those match and you can solve. Your boundaries are a and b. That's whatever height you're integrating from, or whatever your final integration step is. Same thing with y. Integration with y and d of a. Same thing, you're using a rectangle, base times height. This one can be a little bit different because you're solving in d of y is now where your steps are at. In this one, we were taking steps of small sections along the x-axis. In this one, you're taking steps of small sections along the y-axis. And you have to be in d of y. That means that in our equation, we have to have y instead of x. So we have to switch this, what used to be y equals x squared, into x equals y squared, or whatever your equivalent is, because you need y in the equation if you're differentiating by d of y. That makes sense. So that was my big reminder on centroid and moment of inertia. If you're solving with d of x, you have to have x. If you're solving with d of y, you have to have y. That's just simple switch, and that's what's giving you your height for your changes. Also, this one can be a little weird, depending on if your kind of like section is up here or down here. You're gonna need to change if it's like your y or like b minus y, if that makes sense for your height. Okay. Then for moment of inertia, it's kind of your point of rotation or your point of bending. You're doing the exact same thing that we just did over here, except now it's with y squared and x squared, and there's nothing on the bottom. But you're doing the exact same thing to get your d of a and your d of a. You're doing your base times your height of your rectangle. You're cutting it in sections. You have your d of y, your d of x, and you're doing the same thing. It's the exact same process for moment of inertia, just different equation. Then finally, for mass moment of inertia, or for a rotated object, you either have a shell method or a disk method. A shell method would mean it's hollow on the inside, so you're looking at something like this shape. If you're doing something with a disk, that's mean it's filled in the middle, and you're looking at something like this shape. So these in purple are the equations that you have for either of those methods. This one you're differentiating with r, this one you're differentiating with y, and that's how you need to set up your dv. Same thing that we did up here, but now it's a little bit different because it's not a square that we're taking sections of. Now it's either this kind of hollow cylinder or this cylinder. And the equation that we have for dv is these two: radius, height, and thickness. Radius, height, and thickness. Radius, height, and thickness should be on that one as well. You're doing that exact same process. It's going to look a little bit different because based off of every kind of graph, where your d of y's, your d of x's, or your r's are at, but you're always kind of looking for those same variables, and you're just finding the area of sections. You're going to keep looking for the sections, find d of y or d of x, and whatever this equation has in it with your r squared or your y squared, that's what you need to be solving with if your d of y and your d of x. Those always need to match.